All right, so this is the lesson on simple machines. So let's go to it. This is in Unit 6 for the high school, and just in general for the middle school, it's good to know as well. So if we're looking at this, I'm just going to swap my displays here. Simple machines. So we have 6 simple machines. We have the wheel and axle, we got the pulley, the lever, the incline plane, the wedge, and the screw. So looking at these, what we do with these simple machines is work. And work is a transfer of energy from one system to another. Mechanical work is a product of magnitude of force in the direction of the displacement. So to do work, you actually have to displace something. So like if I'm just holding something like right here, I am not doing any work. Work has to happen from me moving it in a direction. Like this is work because work has movement. It's displacing and exerting the force at the same time. If I am just exerting a force by holding this, but I'm not displacing it, that would be a force of something times 0, which is no work. So it has to move in a direction to be displaced, which means you need the displacement and the force at the same time. So work indicates that force is being exerted and it is moving something. So it needs to be moving something. That is an important concept of work. And simple machines make work easier. So going through the 6 simple machines, you have the wheel and axle, which is 2 connected circular objects of different diameters. So like steering wheel here, we got the wheels and the axle for this duck. A doorknob's got a wheel and axle. Bike tire, Ferris wheel. Right here, this conveyor belt, you got the bearings that are wheel and axles. So wheel and axles are 2 circular objects of different diameters that one rotates around the other. You got gears, which are kind of like a specialized wheel and axle. Like as you see here, we have a circular object that then has teeth around another circular object. So gears are like a special example of a wheel and axle. And usually they're used where one set of teeth is going into another set of teeth to get movement out of them. And then we have pulleys, which is kind of like a wheel and axle, but you run a rope through it. And the cool thing about pulleys is, one, they change direction, but 2, you can get a mechanical advantage on them. So like we got different examples of pulleys here, lifting a shipping container on a fishing rod, once again, shipping containers. And here's the cool thing about pulleys. So with a pulley, you can just change the direction of your force. Your force is being pulled up by you pulling the rope down. It is still 10 pounds the whole way. But if you get a set of pulleys like this, you can actually reduce the amount of work you have to put in to make the object go up. So like this 80-pound object can be raised with only 10 pounds of force if you use the right pulley combination, because it reduces the effort required. You just end up pulling more rope. All right, so we got a lever, which is a fixed point, a fulcrum, around which something rotates. So there's different examples of lever. You got the lever right here, that's the fulcrum. You squeeze that, you can put the crowbar in something and squeeze that. You got a teeter-totter here, there's the fulcrum. So a lever basically has 3 components. And those 3 components are the resistance to force, or the load, the effort you're putting in, and the fulcrum. And they come in 3 classes. So you have your first class lever, which is like a seesaw, where you have your effort on one side, your resistance on the other side, and then right here is your fulcrum in the middle. A second class lever is like a wheelbarrow, where the fulcrum is on the end, and your resistance, or the weight that you would put into the wheelbarrow, is in the middle, and then your effort is on the far end. So this is a lever of the second class variety. And then the third class lever, that's more like, like your elbow, where the fulcrum would be your elbow, and the effort you're putting in is here, and the load or resistance would be whatever you're holding. So that is like a third class lever. We've got an incline plane, which is any slanted surface that can be used. So we've got ramps that you see is probably the most common, or on a road you see like this off ramp. And then we have some specialized incline planes, which are the wedge and the screw. And we're going to go into some more details because they have to do certain things. So a wedge is an incline plane that moves, so it's got to have a motion. It is typically triangular in shape and sharp, like this razor blade here. And here's the big thing: wedges make a splitting force. They split, cut, tighten, or hold things together. So, like this nail, it wedges into the wood and it creates force on the wood where it pushes the fibers of the wood to the side and makes a really strong hold. The saw's got teeth that exert a splitting force. The knife's exerting a splitting force. So all of these things here are exerting some kind of splitting force, and that's the key. It makes them a wedge and not an inclined plane. A screw is an inclined plane that is wrapped around a shaft, and it's used to fashion things together and move. So basically, what a screw is an inclined plane that instead of just going in one direction, transfers um, a circular direction into a linear direction. So instead of going circular now, it's changing that circular direction into a linear direction. So that's what it's doing. It's a specialized inclined plane that changes a circular direction of movement into a linear direction. So like here with this auger, this is spinning circular, but it's moving things in that linear direction. Same thing here with this worm gear. It spins circularly, but it's moving the gear on top of it in a linear direction. This parking garage is circular, goes around, but it changes to that linear direction of going up the whole way. So these are the 6 simple machines. All right, so let me just get out of here quick. All right, so your assignment for this is to paste a picture into each of these boxes. So most of them have 2, like you need to do 2 inclined planes, 3 levers, so 1 first class, 1 second class, 1 third class, 2 screws, 2 wedges, 2 wheels and axles, and only 1 pulley. So that's what your assignment for the simple machines is going to be. It's like a scavenger hunt. You got to go out and find your pictures for this assignment. So you should go around your house and start looking. If you can't find anything, you can draw examples. I just ask that you don't pull pictures off of Google. Try to do your own pictures to find the following objects. And follow the directions for when you have to turn this in. So that is what I have for simple machines. Good luck.